that some of the it show the very good binding affinity with 1DP1 proteins, just like the 1D vitamin D. And here I have found that this vitamin D, modified vitamin, modified lithocholic acid, it's showing the very good binding affinity than the normal lithocholic acid. And then based upon the result, I have selected some of the lithocholic acid for the synthesis based upon their docking result. And here for the synthesis of the 5 compound, that the lithocholic acid, the acid group is reduced by by using the lithium aluminum hydride to give the primary alcohol. Here now we have in the structure one, we have the primary as well as the secondary alcohol. Then I have chemoselectively protected the primary alcohol. Then subsequently I oxidize the secondary alcohol by using the PDC in the dichloromethane. And this ketones then undergo the hormones Witting reaction, Emmons Witting reaction. It gives the alpha beta unsaturated ether. But in this case, I got the mixture of the E and Z isomer, and that isomer is separated by using the SPLC. And again, that alpha beta unsaturated ester, then the dehydrogen by using the H2PDC. We will get this saturated this ester. Then this saturated ester 5-way treated with the methyl magnesium bromide, that is the Grignard reagent, and we will get this tertiary alcohol. Then this tertiary alcohol, again I have deprotected this protected primary alcohol by using TBFA, tetrabromine ammonium fluoride. It is a very good deprotecting agent from for the TBS. Then again, that's primary alcohol selectively oxidized PDC, pyridinium dichromate. We'll get the aldehyde. This aldehyde is again the further oxidized with the oxone, and we'll get this our 5-year product. And I have found that I have synthesized this other derivative also, but we have found that this 5-year, it shows a very good binding affinity with the VDR. And this work is published in the bioorganic chemistry, and the same compound we have patented in the Spanish patent. That this is the patent number W. And again, the molecular iodine is a versatile reagent for the synthesis of the variety of the antibiotic, anti-cancer, antifungal, antiviral, and anti-HIV organic compounds. Thank you very much, sir.
Thank you, Dr. Gaikwad, for your excellent work, voluminous work, and by use of molecular iodine.
Yes, sir.
Now, I request the audience and the judges to ask questions. There are a lot of materials to ask questions. No question. Actually, you have explained in such a way that there is little scope for questioning. I am asking one question.
Yes, sir. Yes, sir.
Professor, sorry to interrupt.
Sorry.
Oh, sorry to interrupt, Professor.
No, Professor.
Yeah.
Please
thank you.
You ask question.
Yeah. Dr. Gaikwad, right?
Yes, sir.
So did you try with any other dihydropyridine derivatives for the oxidation using this iodine DMSO to get substituted pyridine derivatives?
Substituted beta carbolene.
Not this, sir.
Quinoline.
Dihydropyridine.
For the synthesis of the dihydropyridine.
No, the dihydropyridine will be synthesized by the Hans dihydropyridine synthesis. There also we use some oxidizing agent to get the substituted.
Yes,
you will get the 5 substituted.
To win this round,
yes, sir, but
stay in the Ultimate
no,
Soul
sir,
Challenge.
because I use only molecular iodine for the
win this round,
dehydrogenation and the
it goes to
synthesis of
sudden
beta
death.
carbon, variety
And
of
whoever
beta
wins that
carbones,
round
and
stays
there
in the
are
Ultimate
many
Soul
methods
Challenge.
available for the
All right, gentlemen,
this dehydrogenation of this
head back to your
beta
start
carbon
positions,
to
please.
beta carbon, but there is no method
Had my
available
share,
for the
not
synthesis
fighting.
of the
I never
aromatization
underestimate
of
my
this
opponent.
tetrahydrobeta
That is
carbon
my
without
keyword now. I'm
decarboxylation
gonna
at
go
the
there
C3 position.
with 110%
That will happen only
respect.
by
So
using using the enzyme that is the FCBB that is secreted by the E. coli, and there is one method that is KMNO4 at a low temperature, and it also uses this aromatization without decarbonization of this. Here we have developed the method by using molecular iodine for the aromatization of this beta carbon to the this and again we use this iodine by using the external oxidant or the for the aromatization of this tetrahydrobeta. We have used this at one stage only. We synthesize this flavonol because we protected this OH, the allele group, and our this methodology used for the allelation and the de-allelation, and by using the iodine DMSO H2O2, by use of the H2O2 there is no de-allelation. So we have used applied this methodology for the synthesis of the O allele flavonol.
Aaron brings it home
Thank you.
all the way, winning it for the Americans.
Thank you,
Here's
Dr.
how he
Hello.
did it.
Gaikwa,
Aaron
for your
uses a
nice
more
presentation.
direct approach.
I
As
have
Ben
one
used
very small question. You have lot of
Yes,
new
yes.
compounds actually.
Yes, sir. Yes, sir.
Have you?
Sir, Malik sir. Hello.
Yes.
Yeah, sir. Please, I need to show the first slide.
Yes, sir.
Hi, I'm Simon and I specialize in calisthenics, which is building strength through bodyweight training, utilizing exercises
Dr.
such as the
Sarkar, please
planche,
ask a question.
human flag.
Dr. Sarkar.
Yep.
Hello.
That's me.
Yes,
Hello.
sir.
Malik sir.
I train
Yeah.
in core martial
Yes,
arts.
sir.
So, as per the list is concerned, title of the paper was chemistry, coronavirus, and treatment. But I think so now it has changed your title.
Yeah, sir. No, sir. Actually, my student, BSc undergraduate students, he was giving the presentation for the treatment with the chemistry and the coronavirus. By mistakenly, he submitted my in my registration.
Okay,
Yeah, like this,
Okay,
sir.
okay,
Yeah,
okay.
it was. Yeah, it is by mistake, sir.
So we're gonna have to demonstrate what
Because
we're doing this morning.
my 2 to 3
utilize
students, they are also
all the
present in
instructions.
undergraduate course.
Okay.
Yeah.
How this can act as
My name is Sergeant
this can
David.
be
Today
active
we're gonna be
against
going over
the
the shoulder flow.
coronavirus.
The shoulder flow
These
is in the
molecules,
green belt
these
syllabus.
molecules.
Now,
This
before I do
sir,
anything,
is
right now that you're
actually,
in
sir,
a
this
demonstration
beta
position,
studied?
say demonstration position.
Yeah, yes, sir.
Done the binding
Okay, now
studies.
what I need you to do
Yes,
right
sir.
now,
I
go
did
ahead, stand up,
the
with somebody of
molecular
equal height
docking
and equal weight.
study
Please do
with
that.
the
Purpose of this
lithophilic acid
technique is to take
derivatives,
your opponents to the
but
deck and de-escalate the
in
situation. Does
concern
everybody
with
understand
the
that?
beta carbolines,
All right,
and
next,
beta
I have
carbolines
my
are the
principle.
generally
Now, my
they are the
principle is BBLT.
isolated from
Body
the
position,
sativa,
balance,
that is the
leverage,
fruits
and timing.
initially,
Body position.
and that fruit
Body
is
position,
used
you
for
want to
the
ensure that your
treatment
body
of
is
the
properly positioned so that way you can
malaria.
actually execute the technique. Does everybody understand that?
There are so
Balance.
many
You want to ensure that you have proper
beta
weight
carboline
distribution throughout
derivatives
your body so that
act
way
as
when
an
you actually execute
anti-malarial
this technique,
agent,
you are not
and
disrupting your
we
own
can
center of gravity. Does
and
everybody understand that?
there is a
Leverage.
Manjiman
You will use your opponent
natural
as a lever
product
to
belong
take them
to
off
this
of the ground, up
beta
in the air, and
carbolines.
back onto the ground.
Maybe
Does
that
everybody
may be
understand
act as
Fundamentals.
against our
We have
this
entry of balance,
coronavirus.
execution, and angles of movement. Does everybody understand that?
Based upon there is one
Entry
report
is me
also
actively
available
invading
in
my
the
opponent's
recently
center
in
of
published
personal
the
space. Does everybody
2001,
understand? Off balance is me
2021
disrupting my opponent's center
molecular
of gravity.
docking
Does everybody
and the
understand that?
for the coronavirus.
Execution
There is
is
a
me bringing
series of
all
the
of
beta
them
carboline
together and
derivatives.
taking
That
him to
is
the
some
deck.
of
And last
the
but not least, I
derivatives
said
and some
angles of movement,
some
and that's
natural
me
products are
actually
there
executing that
which
angle of
act as
movement to,
the
to disrupt my
coronavirus.
opponent's center of gravity, to take them to the deck.
Drugs.
Everybody tracking.
Now,
But the virus is changing. You have to also change.
Yes, sir. Virus is changing, so that is the virus is just changing their DNA sequence.
So thank you very much for
Yes,
your
sir.
nice presentation. For lot of
Thank
work.
you.
Lot of work.
Thank you very much.
We have one more residual paper, that is Kanhaiya Lal. Kanhaiya Lal, paper number 19. Possibly Kanhaiya Lal is present. Kanhaiya Lal,
One hand over the other, one hand over
is
the other.
Kanhaiya Lal
What they're doing now
is Kanhaiya Lal
they're
present?
warming up. So they're basically doing something to get the heart rate up so they can initiate.
At the
Marine
beginning, I
Corps
called his
martial
name
arts that
twice.
they perform at the
He was
end.
not present.
So what I'm
He
doing
came-
is
Now
I've been
also
doing
he
this
is
all
not
day.
in the
I went through a
participant.
series of instruction
He
earlier,
came,
and
now also he is not here.
I'm gonna
then he
just
came.
throw somebody.
Then he
Yeah.
requested
Throw me.
that I shall present now. By phone's battery will run out. Now where is he?
No,
Can I
he's
allow-
not here.
So possibly all the papers, particularly where the presenters are present here, they have been completed, and I must thank the speaker and audience and the adjudicators for their nice questions and for their nice questions. And actually we have, particularly myself, has learned a lot from different types of papers presented here. And definitely we will next contact Professor C.R. Sinha or concluding this session. And we have to assess the papers and we have to award marks 10 for material, 10 for materials, 10 for presentation, and question answering 25 out of 25. All this possibly I am asking Professor Sinha. We will send this to him, the marks. Or Rahul, I can see Rahul also.
Yes, sir.
Shall we send our assessment marks to you, or in which way we will send it?
Sir, in the National Science Day 2022@gmail.com.
No,
Compiled marks.
compiled. So we have to see again.
Sir, you can discuss it with Chirantan.
Okay. National Science Day.
Chirantan is here.
Chirantan is here.
Thank you.
Oh, we will send our assessment marks to Professor Chirantan.
Chirantan.
So let him collect all the
Always bleeding
details
somewhere.
and bring out the
Always
best
bleeding
one.
It's all good.
Chirantan.
When I
Chirantan.
was
sir.
on
Yes,
behalf
sir.
of
Are you
Bronco, I
here?
was gushing blood.
Yes, sir.
Will
I am
send-
here.
We'll send our marks
So
to
it
you.
was fun.
Rahul da?
Yes, sir. Chirantan, you can compile it from collecting it from Siva Murugan. Dr. Siva Murugan is there.
Okay, then should we compile all the marks?
Marks and send it to us.
We send to Chirantan Baku or we send to National Science Day
First thing you need to
2020,
understand is that
2022. Which
No,
way
no,
right?
no. You send it to Chirantan.
Yeah, he will compile and then we will
Compile
send
and
only,
then Chirantan
Yeah.
will send it.
Chirantan.
we will send only one assessment sheet to Dr. Rahul.
No, no, no. Chirantan. To Chirantan, and finally compile result I will collect from Chirantan.
Yeah, that's what I'm saying.
Yes. Yes.
Yeah, Dr. Bhaskar, can you please share your mail ID to the message box? It will be helpful for us.
Right, I am sharing just now.
Okay.
Sure.
Someone or your nice
Congrats, sir. Good afternoon.
Thank
you.
Yes, sir.
That time I was talking to Rahul over phone.
No.
So suddenly I was out of place.
না না না
Anyway,
মানে ইন্টারেস্ট দেখি আপনি এখানে আছেন ভালো প্রশ্ন করছেন
no, I always try to be present.
I enjoyed this
Thank you.
active participation of the
Yes.
judges and the members of the audience. Definitely that is a matter of enjoyment to me. Okay. চিরন্তন চৌধুরী রায় চৌধুরী মেল আইডি কোথায়?
চিরন্তন চ্যাট বক্সে লিখলো এই মাত্র।
আমি চ্যাট বক্সে দিয়েছি।
আচ্ছা দিয়ে
রাহুলদা,
হ্যাঁ
ওই সব দাসদেরকে একটাই মেল করে দিন না, চিরন্তনদার মেল আইডিটা।
হ্যাঁ দিয়ে দিয়েছি। চিরন্তন চ্যাট বক্সে লিখে দিয়েছে।
স্যার
Rahul, when the next session should start right away.
Sir, the program is running.
Running.
Competition. There are 2-3 more competitors.
Okay, but it's not parallel, right?
No, this is the same link.
Same link. Then I mean the speaker will be waiting. He should be informed when this session will be starting. It was supposed to start at
Have you informed
3:30.
সমরেশ স্যার,
Yes.
I had informed Professor Ayan Dotto, Dr.
Okay.
Tapon Misro, and Mr. Vikas
Yes.
that we are running 20 minutes late.
So when should we start? Tell me. Because I need to be informed also, right?
Yes, sir.
Hmm.
So, sir, at 4 o'clock.
4 o'clock. Okay. Okay. Thank you.
CRS, sir.
Within 4 o'clock, I shall send the marks to Dr. Rai Choudhury. That is CR Choudhury, CHOUDHURY.
CR Choudhury 2000 at yahoo.com.
At yahoo.com.
আমাদের স্যার আপনি কি ইউনিভার্সিটিতে?
Yes. I'm in university. So Rahul, this session will start at 4. That's what I understand. Okay.
হ্যাঁ স্যার আরেকটু সময় লাগবে
4:30.
No, 4.
4. Okay. Okay. Okay.
কোন দিকের কম্পিটিশনটা হচ্ছে রাহুল দা?
গ্রুপে 5-6 এর তো অনেক বাচ্চা, ওরা খুব চেঁচামেচি করছে, ছোট ছোট বাচ্চা তো।
বাসুবাবু কন্ট্রোল করছে মনে হয় নাকি?
না, ওটা হিমাদ্রি বাবু করছে।
ও আচ্ছা। ফার্স্ট স্পিকার অয়ন্দা?
হ্যাঁ
Rahul.
But are they sharing the same link? Because we are.
Yes, sir. In this link.
Where are they? We are linked already, but we don't see anything. I mean.
No, other from class 5 to postgraduate, there are different links.
Okay.
রাহুল, আমরা কি করব, মানে ভাগ করে দেবো না টোটালটা দিয়ে দেবো?
টোটালটা দিয়ে দিন চিরন্তনকে।
আচ্ছা, ঠিক আছে।
হ্যাঁ স্যার, আপনারা টোটালটা দিয়ে দিন। উনি তো দিলে 25 গুণিত 4 জন না 5 জন হচ্ছে, টোটালটা আবার করে ফেলবেন দিলে ভাই।
আমি তাহলে আউট অফ 25 দিয়ে দিচ্ছি।
হ্যাঁ।
ঠিক আছে, থ্যাংক ইউ।
স্টুডেন্টদের লিংকটা ঢুকে পড়লে হয়।
There is nothing here now, so we can take a break now and come back at 4.
Tea, sir, again tea.
Since we have to start our other program. Sir, one more candidate is left. One more candidate, Yamamoto, who is from Akitsu's lab.
No, it's okay. I can wait. There is no problem. But the speaker should be informed that we are running late.
The speaker as well as chairman both should be informed. I have already informed Rahul that.
No, it's okay. It's okay. Professor Sinha, don't worry.
Thank you, sir. Thank you, sir.
Yes, I am told that this session will be delayed by another, I don't know, another 10-12 minutes. It was supposed to start at 3:30.
Yeah.
It's already 3:49 now, as I see in my laptop. So you have to wait. They told me that the organizers that you have been informed already.
Yeah, so they told me it will be late by 15 minutes.
Oh, okay.
Yeah, so I joined after 15
So
minutes.
further delay.
Okay.
Maybe a few more minutes.
Right. Right.
Okay.
No problem. No problem.
Okay.
I'm here.
I am also.
Yes, Professor Datta, few more minutes, sir.
No problem. No problem.
Yeah, sure.
Okay.
So we are now ready, sir. Hello, good evening, everybody.
Yes.
So we are now ready to start our next session. Since we have finished our competition and the judges are now compiling their data. And this is a lecture session. And in this lecture session, the chairman, Professor Somaresh Bhattacharya, he does not need any introduction to introduce amongst the audience, but well-known teacher as well as scientist and Bhatnagar Awadi as a professor of chemistry, Jadavpur University, along with the Indian Chemical Society. He is the editor of Inorganic Chemistry section. So I do request Professor Bhattacharya to take over the charge and to start the proceedings.
Okay. Thank you, Professor Sinha. As we are running a bit late, I would not waste any time. Okay. See, in this session, the very first speaker is Professor Ayan Datta from the School of Chemistry, Chemical Sciences, Indian Association for the Cultivation of Science. And he is a very well-known, computational chemist or theoretical chemist among the chemistry community of our country. He is very well known. So he does not really need any big introduction, but let me briefly mention that he is already, in recognition of his outstanding research contribution, he has already been awarded with the Young Scientist Award from INSA, and he is a young associate of the Indian Academy of Science. He has received the B.M. Birla Prize in Chemistry in 2017. He has received the third Distinguished Investigator Award in 2019. He is the Associate Editor of the Bulletin of Material Science, and he is in the editorial board of several other journals, international journals, of course. So with this brief introduction, it's really my genuine pleasure to invite Professor Ayan Datta to deliver his talk. Professor Datta, please.
At the outset, hopefully I'm audible to all of you.
Yes, yes, you are.
So at the outset, let me thank the organizers for this wonderful event. And this is an event which is, in a sense, kind of originated from here. And if I may say so, because this is National Science Day and which was done by C.V. Raman in ISCS.
Absolutely.
And so I think I am also grateful to the organizers for inviting me to give a lecture here. And I'm specifically thankful to the chairperson, Professor Shomonis Bhattacharya, whom I know very well, and as my next door colleague opposite to the road, and such a wonderful person. And so without wasting time further, let me go back to my topic, and I will try to share my screen.
Yes, yes. Yes, we can see full screen, no problem.
Okay. So what I'm going to talk to you about today is this weird example in quantum mechanics, and see whether it has some consequences for the way we understand chemistry. Chemistry in terms of the structural reactivity, and then I will try to go through it, and I will try to give general examples, most of them from our efforts in our laboratories, and then try to make connections with the bigger picture, if we can make it. Okay. Now, of course, we know as as chemists that one of the very important theories which has been able to, and I'm told by theoretical physicists that even these transition state models are applicable in which the way in which ants climb hills. So the in general concept is reactions occur. Reactions occur because most of the time the product is exothermic, in the sense the delta G is negative. And most of the reactions do have a barrier, and the rate in which a reaction gets converted into a transition state is governed by the energy difference in the transition state, which we call as the activation rate. And Arrhenius empirically observed it that the rate of the reaction actually goes as the exponential in the activity. So, of course, what are the, if I may say so, what are the recipes for a fast reaction? Well, the recipe for a fast reaction is to heat up the system. If I heat up the system, now my system is no longer in the state, but somewhere here at the vibrationally excited state. Now, of course, I require much lower amount of energy, I mean activation energy, to jump the reaction, and therefore my reactions are going to be faster. And of course, what people do, people use a catalyst. What a catalyst does, of course, it does not change the energy of the reactant and the product, but creates low energy intermediate somewhere in between, which allows the reactions to occur at a lower activation energy. So now the third paradigm which I'm trying to introduce here is to use quantum mechanical tunneling, and I will try to show you that this has non-trivial role in reaction rates of several examples. Okay. Now we know for sure in chemistry, we know two factors. One is the kinetic control and the thermodynamic control. When we talk about thermodynamic control, we say that if a reaction is allowed to occur for a very long amount of time, eventually you get the thermodynamically controlled product, in the sense the reaction which has the more negative delta G would be the thermodynamically controlled product. But as we know, chemistry in a realistic sense is not about thermodynamic control but kinetic control, and as a result, most of the reactions which we find are the examples which are kinetically controlled product. And if I may say so, and we all know this, that out of graphite and diamond, we know that the kinetically controlled product, which is diamond, is the one which is more important. And given an opportunity, all our diamond rings for several thousands of years would get converted into graphite, because graphite is a thermodynamically controlled product, whereas diamond is kinetically.
Professor Mollik, please mute yourself, Professor Mollik. Professor Ashok Mollik.
Okay. So
please mute. Yeah. Sorry.
Thank you. So now the point which I'm trying to make here, and this is a concept which has evolved over the last decade, and particularly by the work of Peter Steiner and several other workers who have been able to show that reactions occur not only
Professor Mollik, please mute the microphone.
Okay.
Yeah. So the question is, there have been several reports by Peter Steiner and several other groups which have shown that reactions For example, consider the case of this carbene. Now, this carbene can undergo isomerization. One of them in which this OH bond the hydrogen will migrate from a 1,2 hydrogen migration from this oxygen end, or a 1,2 migration from the carbon end. And of course, we know that OH bond is stronger than a CH bond. So, of course, what you expect kinetically, the reaction in which the CH bond migration occurs is the kinetically controlled product. But what is observed, certainly at low temperature, is that the OH bond migrates. And this is because even though OH bond has a higher barrier, but remember that because of this OH bond, it is a better hydrogen bond donor. So of course, this width of the reaction is smaller. And now there are several examples from our group as well as where we have seen that reactions are not necessarily governed by thermodynamical control and kinetic control, but it is more important, and certainly at little lower temperatures, where it is the tunneling control which is important. And I will show you subsequent examples from here. Now, this is just a kind of a simple maths in which we know that if you have a parabolic barrier, and this is what we teach in our undergraduates as well. So if you have a parabolic barrier, the probability of things moving from this end, from this end, from the reactant end to the product end, is given by the exponential of the gap. Now, of course, if you write the frequency in terms of the time domain, so what you will get is an equation like this. Now, this equation reminds us of the Heisenberg uncertainty principle in terms of the energy and the time. So, of course, we know we have this very strange case. Let us assume my particles are somewhere here, in the sense my delta E double dagger is now 0. Then I would have expected that the reaction would have a barrier of 0. So then all of the reactants would go from here to here. But if you look at it, the probability is only half. And this is exactly what quantum mechanics tells me, that even if my particles have all the energy go from here to here, there is this strange thing called quantum mechanical reflection, which reflects the things back. And then this is what we would get. So we would like to see some of these very old predictions of 1930s and 1940s, Vignard and Eckart. Some of these are now being realized for realistic molecular systems. So what would be my consequences for quantum mechanical tunneling? Well, yes, one of them, the reaction is going to be faster, because now the molecules are not only going to climb the barrier, but are also going to tunnel through them. So of course, what is my, what would I say? What would be my diagnostic evidence for that? My diagnostic evidence would be that my Arrhenius plot will no longer be linear, but would be curved, and would be curved progressively more and more as I go lower in temperature. And the third thing which is there, of course, we know that if you look at hydrogen and deuterium is heavier than hydrogen. So hydrogen in a sense is more quantum mechanical, whereas deuterium in a sense is more classical. So the ratio of the isotope effect, which is the rate in which hydrogen and deuterium tunnel would actually be more. So of course, large isotope effect would also be a prima facie evidence that quantum mechanical tunneling is important. Okay, now this is what we say. Now, so let us prove it. And now this is something which has been an evolving story. So consider this case, and now this case is something which we all know. This is 1,5 hydrogen shift in a kind of a co-rearrangement. So you see this hydrogen moves from this end to this end, and this is a degenerate reaction. Now, of course, there have been efforts to actually look at this reaction, and people have found out the Arrhenius plot. And what you see from the Arrhenius plot is that it becomes a straight line. Now, I would say this is an absolutely heroic attempt, and I would say it is an heroic attempt because when this was done by Bill Deering in Harvard, when he was only 98 years old. Now, you see, I don't know what I would do when I am 98 years old, but this is the see. The question is when you try to cool down the reaction, because when you want to plot the Arrhenius plot, you would like to, if you want to get more points, you have to wait for more time. Now, you see, as you reduce the rate, as you reduce the temperature, the reaction rate gets slowed down. So Bill Deering at an age of 96 had to wait for 1 year. Look at the half-life of the reaction at 350 Kelvin. And he was 97 when he wrote this paper. And by the time this paper got accepted, he was probably 98 years old. And then you see, if you look at this line, this looks like a straight line. And that's what Bill Deering said in his JCS paper, saying that tunneling effects is likely, in opinion of some, which is he himself, remain relegated to the virtual world of calculations. So in other words, tunneling effects are important, but they're important only for computational people like us. So what Bill Deering says that this has probably no consequences in realistic chemistry. So now, of course, what we did actually to look at some of his data, and then you see that you can look at the local slope, And you see, as you go lower in temperature, the slopes are actually temperature dependent. So then, of course, we said to Bill Deering that, listen, your activation energies are temperature dependent. And then Bill Deering says, forget all that, because you see, these are experimental number, and in experimental science, there are uncertainties. So don't take these numbers very seriously. So the point is, do we have realistic indicators which we can tell to an experimentalist and try to convince a real experimental chemist that tunneling is something which you should look at, particularly not always at low temperature. So I think we thought we will find out examples where tunneling effects are important, and important not at very low temperatures, and things which have direct consequences. So I think the first example which we decided to work on was this case of this hydrogen transfer in thiopropolone, in which you see this is an intramolecular hydrogen bond, and the hydrogen moves from the oxygen end to the sulfur end, right? Now, if you look at the experiment, and this is where we got interested. Now, interestingly, the group in Japan, they looked at the reaction rate, and interestingly, they found that this reaction rate was completely independent of temperature. And in fact, across even the temperature to even as high as 300 Kelvin, the temperature did not show any temperature dependence. Now, this is something which you would always expect if the reaction is occurring through tunneling, because you see that the effective probability of tunneling is independent of temperature, because your Arrhenius plot has curved out. Now, what would happen if the reaction was occurring through over the barrier transition state theory? We know that across this temperature, the reaction rate would have been increased by 1 lakh times. Now, this is what we showed. And what we showed that, if the reaction is occurring through tunneling, your reaction rate is virtually temperature independent. Its reaction rate only increases by 1.6 times. Whereas, if it was occurring through a classical process, this would be changed by 1 lakh times. Now, the question is, why this reaction only? What is so special about this reaction? What is special about this reaction is, remember, the hydrogen moves from, it is an intramolecular hydrogen bond, and the hydrogen moves from an oxygen end to the sulfur bond. And you see the width of the reaction, how much by it changes? It changes by only half an Armstrong. And half an Armstrong is something which we theoretical chemists like wonderfully, because half an Armstrong is exactly the radius of a hydrogen atom. The average radius of a hydrogen atom is about 1 Bohr, right? So this is something, because the width of the reaction is very, very small, and the height of the reaction is also very small. So we thought we have an example where quantum mechanical tunneling is being seen in an experiment. Okay, so now we go to another example. So this is kind of a more detour to show you realistic chemical examples where we can actually see evidences for tunneling. Now, this is again an example of a carbene in which the carbene can dimerize, and there are many ways a carbene can dimerize. One of them is that, the carbene can also have a hydrogen movement, 1 to hydrogen shift. And what we find that if you look at the barriers, and some of the reactions, for example, there's a very small barrier. Now, a small barrier is something which is wonderful, because then you can see an example where you see the reactions inclusive of tunneling is half of the reaction which is exclusive of tunneling. And why is it so? Well, we know the answer, because classically we know if the barrier is small and the particle has energy which is higher than the activation energy, then you would have expected all the particles will move through. But then we know from quantum mechanics tunneling that there is something called a non-classical tunneling or non-classical reflection, in which only half of the particles will move through. And this is exactly what we observe. And you see the reaction rates, if you look at the reaction rates inclusive of tunneling, are half of that you expect from classical. So of course the point is, quantum mechanical tunneling would also lead to non-trivial enhancement in reaction rates, which are not always very fast. In some cases it can be even slow, and almost half of the cases where you can have quantum mechanical tunneling. So you see, the point which we made is that tunneling can also lead to counterintuitive slower reactions for reactions with slow barrier. And this is something which we thought is something which we thought we had an answer to what Bill Deering wrote long time back, is that we do look forward for experimental tests for our computational predictions, right? So now the third example which we show, and now this is, of course, is a Cumulin system and is an anion. So of course, what this reaction does is a Boltzmann type cyclization. And you see, again, the reason why we are choosing examples like this is because we want the width of the reaction to be very small, because we know quantum mechanical tunneling does depend on the width of the reaction. So of course, we were able to tune some of these barriers, and then we could show that reactions can be made to occur much faster. For example, here we can see, for example, if the reaction was not occurring without tunneling, for example, you see this is the experimental rate, and we see that the reactions which we have with quantum mechanical tunneling show actually much better agreement than when without tunneling. For example, you see the half-life of these reactions are 45 minutes without tunneling and 35 minutes with tunneling. And you see the experimental ones are about 21 to 31 minutes. So I think we are making a case where quantum mechanical tunneling can be important, can be non-trivial. For examples, not always at cryogenic temperatures, right? Why I say cryogenic, not cryogenic temperature? Because synthetic chemistry is done at room temperatures or temperatures which are close to room temperature, right? We also showed an example where you see we can have reductive elimination, and you see this is a reductive elimination reaction in which you see there is a carbon-carbon coupling reaction through a gold catalysis, and then we see that again, because the width of the reaction is small, because you see when you have the reductive elimination, these two carbons will come close, and you see they will go to. So basically the width of the reaction is the distance between these two carbon atoms. And then if the width of the reaction is small, we can again have evidences. For example, if the width of the reaction is small, we can have again evidences where we can show that the reaction rates are highly sensitive to tunneling. For example, these are the experimental rates. These are the rates which we calculate with tunneling. These are the rates which we calculate without tunneling. Now, one might argue that there is still a difference between the two. There is a difference between the two because there is a limitation in which we theoretical chemists can handle solvations. So this is the way we have handled the solvations are through some of these implicit solvation models. Now there is a limit to which we can handle these complexities of solvation. So we believe that the small discrepancies that we have here is because of the lack of proper correlation of the solvent. But one thing is for sure that the results with quantum mechanical tunneling are in better agreement with the experimental numbers. Okay. So what we were also able to show that, because we can have studied the primary kinetic isotope effects and the secondary kinetic isotope effects and the product of the two. Now we know that if there is no quantum mechanical tunneling, the product of the primary kinetic isotope effect and the secondary kinetic isotope effect is equal to the overall kinetic isotope effect when you have all of the systems substituted by deuterium. But this is not the case when you have tunneling, because tunneling is more sensitive to primary kinetic isotope effect because of the mass effect. So this is also something we were able to propose, and this is a very simple concept in physical organic chemistry, which we call the rule of the geometric mean in isotope effects, which we thought can give us a kind of a small idea about how things happen. So I think this is a perspective that Peter Steiner wrote, and then of course these people do cite us some of our work, and in which he says that tunneling is the third paradigm of reactivity. Followed by this, there was an article in Chemistry World in which we were interviewed, in which now of course called to bring quantum mechanical tunneling to the table when we try to understand chemical reactions. So of course this is an evolving period, evolving field, and there are several groups in the world, maybe 5 to 6 groups, and we are indeed trying to make a contribution to this area. Okay, the other system which we have, we thought we will be able to play around with this. Now you see, this is a very interesting reaction because this can have 6pi electrocyclization. This can also have a 1,5 hydrogen shift. Now this is interesting. See what happened, the 6pi electrocyclization has a lower barrier, whereas the 1,5 hydrogen shift has a higher barrier. But remember, when you have electrocyclization, it is a carbon which is moving, whereas when we have 1,5 hydrogen shift, it's a hydrogen which is moving. So hydrogen is lighter than carbon. So now if you are able to reduce the temperature, initially the rate of the reaction will be more for the 5 cyclization, for this electrocyclization, than hydrogen shift. But now if we reduce the temperature, eventually the 1,5 hydrogen shift will overcome the electrocyclization, and then we would have a case in which we will have a temperature dependence of the product output. Now this is something which we thought we wouldn't be able to make a contribution. This is exactly what we see, that the product distribution change about 250 degree Kelvin. So at above 250 degree Kelvin, it is kinetically controlled. Below 250 Kelvin, it is tunneling control. So I think we have a reaction here again in which we can play around with tunneling control and kinetic control. Same reaction. Okay. Now these are examples which we did last year, in which we were able to show that, you see, we know that this is again a consequence. This is something called, which we call as negative hyperconjugation. When we say hyperconjugation, it's an interaction of a field orbital with an empty orbital, right? Now, when we have negative hyperconjugation, it is an interaction of a sigma orbital with a pi star orbital, right? Of a lone pair orbital with a sigma star orbital. Now, what has this concept? For example, this is a carborane in which there is a lone pair on the nitrogen. Now, because of this because of this negative hyperconjugation, the lone pair starts interacting with the sigma star. As a result, we have some kind of a world record in which the carbons have become very, very long. In fact, the carbons can be made, for example, we know a carbon-carbon bond is about 1.54 angstrom. Now, when we are able to push electron density to the antibonding orbital of the sigma, the bond can be made as big as 1.9 angstrom. Now, the interesting consequence of this is because the lone pair is moving, this nitrogen is almost becoming planarized. So as a result, now because the barrier is small, the nitrogen will invert so fast that at room temperature, you will see a planar nitrogen. Now, we all know that the case of the ammonia inversion, right? Ammonia inverts very fast. And as a result, most of the time you will see either it is an umbrella inversion between this structure and this structure. Now, because of this hyperconjugation, the nitrogen can be made planarized. And as a result, you see that is the proof of principle. This is an experimental crystal structure in which you see the nitrogen, this nitrogen is not pyramidalized. The nitrogen is not pyramidalized because of hyperconjugation. The lone pair has started interacting with this bond has become very big. And as a result, the barrier has also small. And as a result, the reaction, the nitrogen is inverting. So I think this was also one of the very rare cases where we were able to find a planar nitrogen in the case of the amine. So this is something which we predicted and which has direct consequences for the experiments. Direct evidence for that quantum mechanical tunneling can lead to a planar nitrogen. Okay. Now this I'm extremely happy that some of our predictions, it does have important consequences. Now this I worked with my senior colleague from ISCS, Professor Sibrata Goswami, and this is an example of a transfer hydrogenation in which there is a nickel catalyst with an azo linkage. Now what it does, this substrate captures the catalyst, these two azo and nitrogen capture these two hydrogen. As a result, you have an oxidation from the alcohol to aldehyde. Now, what Professor Goswami told that he indeed found that the NH and ND stretching frequencies are actually sensitive to the role of the catalyst. So Professor Goswami asked us to look at to try to give us an insight of the reaction mechanism. So we did look at the reaction mechanism, and what we found that the transition state is the structure here has a hydrogen atom transfer reaction, and what we found is the case that the width of the reaction is very small, and that of course rings a bell. And then I requested Professor Goswami that in that case this might be a case where quantum mechanical tunneling can be important. And in an absolutely heroic attempt, and this is what Professor Goswami, as a very senior colleague of mine, decided, I should, if a young colleague tells me to look at something, I will do that experiment. So he and his students took this effort, substituted the hydrogen by deuterium, and looked at the isotope effects. And this is a result which I'm extremely proud to show that, look at this. Now, this is the isotope effects when we have replaced the hydrogens by deuterium. Now, these three are the experimental isotope effects, and this is our computations which are inclusive of quantum mechanical tunneling. Look at it. See, these are an excellent agreement with the tunneling results. Now, this is the reaction rate when you would have when there is no quantum mechanical tunneling. So I thought this was an evidence from our lab from ISCS, where both through experiments and computations and through collaboration, we were able to show that tunneling is important. Now, what is the reaction temperature? Well, the reaction temperatures are not very low. For example, they were like 275, and these are the temperature in which catalysis is important. So we were able to show that quantum mechanical tunneling is not necessarily at low temperature and does have important consequences. Now look at, this is the logarithm of the rate. You see there is substantial enhancement, and this substantial enhancement is because hydrogen is tunneling faster than deuterium. So in terms of catalysis, yes, tunneling is also a catalytic factor which generally we ignore. So I think this is something which we thought is an important consequence in which we were able to connect with the real chemistry in lab and try to show that tunneling is important. So finally, I will stop here. So what are the take-home messages? So the take-home message is, of course, tunneling effects are important, and not at cryogenic temperatures. Well, at very low temperature, when there is no vibrational energy, the only way reactions can occur is through tunneling. But when we talk about realistic reactions can also be occurring through quantum mechanical tunneling. The second important thing is reactivity of the molecules can also be controlled by tunneling by looking at, for example, the example which I showed Professor Sibrata Goswami's work, in which the width of the reaction is small. So if the width of the reaction is small, you can control the fate of a reaction. And finally, there is a lot of news because now people talk about lithium-ion batteries and charging and discharging of batteries. Now you see, lithium is not very heavy atom, and we have done some work in the context of material science when we again see that the lithium, the charging of the lithium ions and the discharging are to a very large extent also controlled. About 40% of it is controlled by quantum mechanical tunneling. And finally, I thought the most important take-home message is probably tunneling is important, and not only for theoreticians, and maybe across several examples of structural chemistry. And I do hope that I was able to convince this general audience of the Indian Chemical Society that tunneling is important in experiments in synthetic chemistry. And I acknowledge my students, Dr. Sharmishta Karmakar, Dr. Deepti Josh, Dr. Nijamuddin, and some of my other students. I am very thankful to the funding agencies, and I thank you all for your kind attention. Thank you.
Thank you, Professor Ayandat, for the wonderful talk. And I'm sure there will be questions from the audience. I have some of mine, but I will save mine and like to hear from others. Dear friends, questions, queries, comments. Okay, let me initiate this interaction with my queries. Okay, the first query that I have is with regard to this, transfer or shifting of proton from oxygen to sulfur. Okay, so if I understood correctly, please tell me. Sorry, Professor Datta, please tell me.
Please call me. Please call me.
I need to be formal here. Okay, so suppose if I'd like to take a snapshot at any given time, at any instant, okay, would it be a 50-50 kind of mixture, or the OH versus SH, or it will be more towards OH or more towards SH? Just a general query.
Oh, this is a wonderful question. See, these people, this is a small barrier and a small reaction.
Right.
So if you are able to take a snapshot, we know one thing, that an OH bond is stronger than SH bond, right? So the hydrogen has a more probability of sticking towards the oxygen. So in the other words of say crystal engineering, that is the word they will say, that the OH-S bond is stronger than SH.
Okay. And the second query is with regard to this gold catalyzed CC coupling reaction. So should we understand that many such reductive eliminations do take place in catalysis, metal catalyzed coupling reactions? So they all pass through this tunneling effect or quantum tunneling?
I believe that tunneling is important. The problem, I will tell you. See, the conceptual bottleneck was, in the sense, tunneling was always important for low temperature physical chemistry. Always it was important. But the idea is to bring it to the table that where even at room temperature, some of these reactions are important in the cases when the width is small, particularly when the width is small and the barrier is not very high. So, for example, we have done calculations across several examples, even in material science, even in molecular places. We believe about many of the reactions are kind of accelerated by 25 to 30%. And I am told by industrial chemists that if a reaction is accelerated by 30%, and that is something substantial.
Yes, and the example that you cited with Professor Sibrata Goswami, that reaction took place little above room temperature, I understand.
Right. No, so I think the reaction was at room temperature. So then, see, the problem is, as you try to reduce the temperature to get an Arrhenius plot, the reactions become slow.
Right.
So, so Professor Sibrata Goswami had to wait, and the student was so patient. So eventually we could go up to 270. And you see, this can happen only in IICs. The student was waiting, I mean, for that one data, he was waiting for 4 months just to get that data because the reactions get slow. The half-life of the reactions are slow.
Right.
It's
And you cited the example of that 96 or 97 years old scientist, Bill. That was really inspiring for all of us. And one last question from me. Okay, that is that nitrogen, planar nitrogen, you referred to towards the end of your talk. Should I understand that nitrogen is going from sp3 towards sp2?
That's right. That's right. It is going from sp3 towards sp2 because of the lone pair is now interacting with the sigma star of a carbon-carbon bond which is sticking somewhere nearby because of this hyperconjugation. So now,
what about the energy matching? I mean, that sigma star versus that lone pair, whatever you will call it.
Right. So this is like the orbital is properly oriented to get it. And then as a result, if you look at the crystal structure, then the nitrogen is almost planarized.
Yes.
And because of the planarized and because of this, because the width is very small, so it creates a very nice case for quantum mechanical tunneling. The width is small, the barrier is small.
Okay.
So
Thank you so much. Thank you so much for this wonderful talk. Any other question, please?
One thing, Professor Datta.
Yes.
Is there any solvent polarity effect on the tunneling process?
Okay. So there are I mean, to a physical organic chemist like me, there is a concept called solvent kinetic experiment. They are there, and polarization was always important. But the problem is, being molecular chemist, molecular quantum chemist, solvation polarization is, unfortunately cannot be taken into account with that accuracy. We do take into account in a kind of a mean field approximation. But if you ask me, can we do it in a much better sense? Probably yes, but not very convenient. I'm sure it is important, but the ways to do it is not very straightforward.
Right. Any other questions or comments? If not, then let us thank Professor Ayan Datta once again for his wonderful presentation. Thank you, Professor Datta. Thank you. We shall now move on to the second talk in this session, which will be delivered by Dr. Tapan Kumar Misra. Dr. Misra is the retired principal of Vidyasagar College, Kolkata, and he is also the vice president of Paschim Banga Vigyan Mancha. He did his PhD in forest ecology from Forest Research Institute, Dehradun. He is a fellow of the Society of Ethnobotanists by the Society of Ethnobotanists. So with this very brief introduction, it's my genuine pleasure to invite Professor Tapan Misra to deliver his talk. You are muted, sir. Please unmute yourself. Yes, now you're, yeah. No, sir, something is wrong. I don't know what it is, but we can't hear you. Maybe the jack is not placed properly.
Hello.
Yes, now we can hear. Yes, please.
Let me thank the chairman of the session. So I must congratulate the participants today on the eve of National Science Day. I'm afraid that I'm an odd man in the August gathering of the chemists. I'm basically an ecologist. At the outset also, let me condemn the use of atomic weapon against any country in the world. The threat is coming from some country. So this will again repeat the history of 1945. So now let me come to my talk. So in Constitution of India, in Article 51A(h), there is mention of scientific temper. And there is also a mention of the spirit of inquiry. So the institutional science teaching research, etc. in India has not moved towards that. We are much away from the, hello? Am I audible? Is there any problem?
Yes, sir. Yes, sir, you are audible.
We are much away from the mandate of Constitution of India, so far as the scientific temper is concerned. And if you look at the history of the world, you will find that people has fought for this. You must, I must remember the work of Shelley. Shelley was a poet of England, who wrote in 1883 a very short poem known as The Spirit. He described a story in his poem. He told that he was walking with his mother in the streets, and he saw suddenly, he was a child that time, he saw suddenly in the street that a man was fastened to a pole, and he was about to burn to death. And some people around us, they stood and they were cheering. They were asking the man to say that the earth is the center of the whole universe. But he didn't tell that. This was the story that has been described by Shelley. It's the story of, perhaps you know, Giordano Bruno, who was killed in 1600. Shelley was not, of course, alive. I mean, he was not born in 1600. He was a poet of 19th century. Still then, this story in the form of a poem, in the form of a poem says, what is the status of scientific awareness in the world? And presently we find many things in our country. Some myths are being given the status of science. You know, science has a process, science has a philosophy, and this philosophy and the process depends on hypothesis, then experimentation, following certain methods, then we get some results, and then we reach at some inferences. So the myths that are being repeatedly told by some section of our country goes against the spirit of the spirit of the Constitution. Perhaps you may be knowing that in 1947, Indian Science Congress, which was held in January in the Delhi, Jawaharlal Nehru, the first Prime Minister, he was, during that time he was not the Prime Minister, because I am talking about January of 1947. So he told in the gathering of scientists in Indian Science Congress that the primary duty of the scientist is research, of course, but the other duty should be to inculcate scientific temper in the minds of our young students. So that is not which we are seeing now. That is not found in the in our curriculum, in our day-to-day life. So I have told the organizers that I will be happy to speak about the climate change and its impact on forests, etc. Because all these things are that will go with the spirit of the theme of this National Science Day today. The theme of the National Science Day is sustainable future. Perhaps you know that when COVID-2, SARS-CoV-2 broke out in China in November 2019, there was a UN cry all over the world. And for the first time in the world, Chinese scientists, with the help of some funding from the bodies, the local bodies, you will be astonished to hear that Aging Corporation funded for this. They made a sequence of RNA RNA virus. This sequencing was published in January 2020 in Lancet. And all over the world, there was a discussion on this. And this is perhaps the first cause why we got a vaccine within 9 months of the outbreak of this pandemic. In Lancet and in other journals also like Science, Nature, etc., the appeal from the editorials came that there should be no patenting on the RNA, so that there can be, say, vaccines that can be made by anybody. No patenting should be there. It was the appeal, but you know perhaps that we are now paying. Some people are paying for the vaccines, etc. But the thing which I want to tell that IPBES, perhaps you know, Intergovernmental Policy Platform for Biodiversity and Ecosystem Services, recently they told that outbreak of such pandemics may occur in future also, because we are losing habitats of wildlife. We are losing habitats of wildlife means the animals are coming closer to us. So the viruses that are there in the animal systems, particularly mammals, they can migrate with some mutations to human body. And that has what actually happened in case of SARS-CoV-2. And it has also happened in other cases also, in case of AIDS, in case of some other diseases like Ebola, etc., etc. So in future, if we lose the habitats, animal habitats, I mean the wildlife habitats, in the rate that which is going on now, we may experience many other pandemics in future. So this has been widely researched, and in 2021, 5th June, or in the World Environment Day, the theme was protect the habitats. It was restoring the ecosystem. We should restore our natural ecosystems. Unless otherwise we restore our natural ecosystems, we cannot survive in future. So that is the main theme that we have. And that is why perhaps the Science Day, in this National Science Day, we have a theme that we have a future, which will have a sustainable future. Science and technology for sustainable future. See, perhaps you know that IPCC, in its IPCC means Intergovernmental Panel on Climate Change. It has published the first part of its report, 6th report, which is known as physical science basis. The second part of this report has to come today, perhaps. The second part is on our adaptability to climate change, etc., etc. So in the physical science basis report, IPCC has uttered many things that are dangerous for human population, as well as for the other populations also. I mean, plants, animals, etc. For every biotic component of this universe, because the temperature has gone up to 1.1 degree centigrade since that of 1750. 1750 is taken as pre-industrial era. So this temperature, the scientists are they are expecting that will go above 1.5 degrees centigrade 1750 by 2030. So that will not sustain. That will not be sustainable for us. We cannot survive in that temperature, because there will be other things that you know. So the Mauna Loa, carbon dioxide monitor that is there in Hawaii Islands in Mauna Loa, that says that within 1952 to till date, there has been rise of 100 ppm of carbon dioxide in the atmosphere. So this is going to rise again. So what we have to do is to check the rise of carbon dioxide concentration in the atmosphere. But the thing that worries us is that take 1972, that was the first environmental summit in Stockholm. And this is the 50th year of first environmental summit of the earth. In 1972, our Prime Minister Indira Gandhi joined that conference. And since then, after 20 years of that, in 1992, we had Earth Summit in Rio. Since 1990, almost every year, this UNFCCC people, United Nations Framework Convention on Climate Change, people from almost 200 countries are meeting, and they are taking decisions, but nothing has been done in the last 50 years. So 50 years is enough for the decisions that has to be taken. Perhaps you remember that only in 10 years, less than 10 years, WTO has been formed. It took only 9 years to form WTO, World Trade Organization. World Trade Organization is a treaty that has, which is internalization of market. Marketing, opening market access in each and every country. And it is a treaty which is legally binding. If some country says that I won't go by the treaty, then he will be penalized, that country will be penalized. But nothing of that sort has been taken in case of carbon dioxide concentration increase. So I can just mention 3 or 4 instances. Say in 1997, Kyoto Protocol was there. In Kyoto Protocol, they have divided the countries to Annex 1 countries and some other countries also, like us, like India. In Kyoto Protocol, the Annex 1 countries were told to arrest their carbon dioxide emission, and that should have started from 2005. But alas, that could not be done. The developed countries, which has been bracketed as Annex 1 countries, they have not done what they should have been. And then let us come to the Paris Convention in 2015. In 2015 Paris Convention, prior to that, each and every country, they provided their NDC, nationally determined commitment to arrest carbon dioxide emission. But USA, as you know, in 2000, after their election, some other president came and he told that, no, we are not going to abide by the treaty. So nothing could be done in that direction. In 2021, in Glasgow again, there was a summit. We were expecting something to happen. That started in November 14, 2021, November 14 in Glasgow. Prior to that, as I told, IPCC report has come, but nothing was done in that direction. No decision was taken. So we are now helpless, and other countries, they are also helpless because they are not in a position to say, ask USA and other countries who are powerful one and who has, say, historically, they have more carbon dioxide in the atmosphere, what we call as historical emission. Almost 3/4 of the carbon dioxide space that we have is filled up by historical emission, and nothing has been done in that direction. So the only way is to protect our forests, the natural source of, the natural way of sequestering carbon. So this natural way of sequestering carbon is at risk now. In Brazil, we have seen that what is happening to the tropical forest, which is known as the most biodiverse forest in the world. Every day, the forest is being burned to make way to the making the grasslands for the cows, etc., to produce milk and meat. In Brazil and in Indonesia, Malaysia, the natural forest are being destroyed for palm oil cultivation. And in India also, we are trying to make this, what we say, corporate forest, production forest. Our forest policies, laws, etc. has been, they are being altered every now and then. During the first, pandemic, fast attack or fast wave of the pandemic, we saw EIA rules of our country has been changed. And this was followed by changing of, say, our forest conservation rule, Biodiversity Act. All this has been changed to make a way for the corporates for going for plantation forests rather than natural forest. As we know that the natural forest has the ability to capture carbon twice than the plantation ones. We, of course, ask for planting trees, but in comparison to natural forests, the plantation forests are helpless. They cannot capture carbon because natural forests can capture 55% of carbon in its soil, and in the above soil vegetation, only 45% of carbon is stored or sequestered. So there is nothing other than natural forest. So we have to go for conserving the natural forest if we have to survive, if we are to survive. The second thing that we are seeing that there is a migration of our forests. And I can give you an example. We have, say, the Dipterocarpus type of forest, sal forest in the foothills of Himalayas in our state, in West Bengal, in the Tarai Duars region. As the temperature will rise, these forests will gradually migrate towards the hill, because the hill temperature will rise, and hill has certain other types of forests which we call pine forest, etc., etc. So this migration of forest from the equator to the polar region, particularly North Pole, is also visible by and it has been experienced by this satellite imagery. So this migration has to be checked. If this migration is not checked, then the whole biodiversity will be at stake. Because the animals, the wildlife, which is there in the foothills of, say, Himalayas, they cannot migrate to the hills. Elephant cannot climb the hills, So the whole biodiversity will be at stake. So this has to be checked. This has to be checked in the natural process, not in artificial process. The other thing is perhaps the forest fire. Every year, 1/10 of the natural forest comes under fire. Forest fire is a great menace to the forest conservation process. Particularly, the pine forest are in stake because, of course, tropical forests are also being fired, as we see in Amazon. The pine forests are in stake because the pine forest has the humus under the pine forest is very rich, very thick, and the pine leaves have some essential oils, and they can catch fire easily. And this, due to cold temperature, the decomposition of the leaves also slow. So humus is the amount of humus is very high in comparison to tropical forest. So there can be, naturally this forest will spread. So this has to be checked. And for this checking for either forest migration or conservation of biodiversity or checking of this forest fire, one possible the opening is to manage forests with the local people. If we can manage forests with the local people, associating people with the forest management process, not only forest, all natural ecosystems, we can perhaps see some light to for survival of the humankind, also the biodiversity of our country. So for sustainable future, that the message of this National Science Day goes, we must ask our younger generation to protect our natural habitats, to protect our natural ecosystems, and that can be way for a sustainable future. Thank you.
Thank you, Dr. Mishra, for your very informative talk. And I guess there will be questions from the audience.
You were not audible.
Hello? Dr. Mishra, what did you say? Rahul or others, am I audible or not?
Yes, sir. Yes, sir. You are audible.
Yeah, I am here.
Because the speaker is saying that he is not able to hear me, but that probably.
Now you are.
Okay. So you have
I am listening.
Some problem with your earphone, I guess.
Maybe.
Anyway, thank you very much for your informative talk. And if there is any question from the audience, it is time to interact with the speaker. So any question?
Sir, one question, one simple question, sir.
Please.
Yes, please go on.
Sir, as per 1972 is concerned, that India, the geographical area of the 32% should be covered by the forest. Am I correct, sir?
Yeah, no, it is 33% actually, and 66% in the hill areas.
Yeah, 33%. But what is the condition at present?
Yeah, that's a good question. Every 2 years, our Forest Survey of India, they take satellite imagery and they interpret that, and they publish a report which is known as State of Forest Report of India. State of Forest Report of India. Every odd years this report comes out. The 2021 forest report had come in January 2022, and it says that we have a say total percent of 22.3 like that natural forest, and trees outside forest is somewhat like 1.9%. At that the total comes to 24%, 4 like something like that. But there are many criticism against this, because the ground truth is not, I mean, that cannot be compared. I mean, that is not comparable to the FSI data that has been given by FSI. This has been told by many experts. There are many papers also in this regard.
Yes, sir. So recently already to this Hindu's paper, I think 1.5 months before that, it is written 22%. This is the total geography is covered by the forest. I don't think this is 100% correct, because there are so many kitchen garden is there. That kitchen garden is under the forest area.
Yeah. You have mentioned rightly. The criticism against this is the rubber plantation and the plantation of coffee
Yes.
in the north, in the Western Ghats. That has been designated as forest. The plantations, agroforestry thing, that has designated in forest. So there are two things that has come to my mind. First thing is that FSI publishes this data, but they don't give the satellite imagery that they have used. So the people who generally interpret, they purchase the satellite imagery from Hyderabad and they interpret themselves. But people like us that doesn't have the money to purchase this satellite imagery, so it is difficult to interpret. This is one thing. And the second thing is that this technology that we have can very well interpret the plantations, eucalyptus plantations, bamboo areas, coffee plantations, rubber plantations, and they can very well differentiate with the natural forest. It is not a difficult thing. But I don't know why is FSI, Forest Survey of India, they have given such data to us. That may be something else. They say that it has international commitment to show that the forest cover in India is increasing.
No, sir, one more thing there. 2009 is concerned, I can say during that time, I was discussed one of this the FSI, Forest Survey of India. That is one of the IFS, Indian Forest Service officer. I discussed with them. They are telling that whatever satellite image we are getting, definitely it is compared with the ground level. If they are
This is called ground truthing.
level, then why such type of criticism going on? Even in the Kerala, there's every year their plantation is going on. And that also coming in the photograph, and it is mean that increases the forest. I don't think it is the correct, sir.
No, I have told you that this is not correct, and there are criticisms
No,
going
sir.
on.
That 2009 is concerned because you also in the ICFRI, I also come from the ICFRI. That is telling this condition because 9 there was discussion with the FRI itself. So they are telling no, it is the correct.
No, I had been to ICFRI and FRI there. ICFRI stands for Indian Council of Forest Research and Education.
Yeah. Because at present I am not the employee of the ICFRI. Then now I can discuss.
Okay, Dr. Shawkar, I need to finish this interaction because
sorry, sir.
Sorry, I'm sorry to interrupt. Okay, so in case there is no other question, I don't see any raised hand. So let us thank Dr. Mishra for his wonderful presentation. Thank you. Thank you.
Thank you.
Dr. Mishra.
Thank you, Dr. Mishra.
Thank you.
Thank you.
Okay, so the third and final speaker of this session is Vishal Mulya. And let me briefly introduce him. He is the principal of Sri SVM English Medium School, Jamanagar. And he has served as visiting faculty in the biology department of MVM Science and Home Science College, Rajkot. He has also served as a visiting faculty in environment science at Government Physiotherapy College, Jamanagar. Besides that, he has given lectures to many academic institutes in Jamnagar and other places. So with this very brief introduction, it's my genuine pleasure to invite Vishal Mulya to present whatever he has in store. We are all eagerly waiting.
Thank you, sir.
Okay.
Sir, my just one question is the screen okay or is it reverse?
No, the screen is okay, but you need to share because it's a small window now where we can see your face as well as the title of the talk.
Yeah, fine. That is the final one. That is the final screen. My video, whatever my video is there, is having the entire screen.
No, but you can share this screen. There is a share screen option at the bottom of your laptop, wherever you are connected. You see, there's an upward arrow at the bottom. That is for sharing this.
You have 6 buttons in the middle of the screen.
See, rather than sharing the screen, my video,
yes,
just enlarge that video. That is having the entire presentation.
No, we cannot do it from our side. Okay. If you only share the screen, then only we'll be able to see it full screen. Otherwise, it's a very small window where, as you can see me probably. So similarly, I can see you within a very small window.
Just a minute. Sir, whatever my video is there, you pin that video. Everybody, please pinning that video.
Okay, so everybody, on your screen, you pin on the, yes, I did that. And now I can see, a bigger view. Yes.
Yes.
So I request all who are present now to sort of pin on this small window where you see Vishal Mulya himself and the title of his presentation.
Yeah.
And thereby you will be able to see it on a bigger you will get a bigger view of this everything. Please,
So-
please start.
Fine. Thank you very much, sir. Thanks for giving this opportunity. Here I am not putting any technical things, but probably you can consider it as the science communication way. And this is the scientific journey of the chemistry in India with special reference to Indian Chemical Society. We have a tradition to have the lighting of lamp. Of course, we would have done in the morning. Sorry, I was not there. But because it is the scientific cartoon, so let me have a little bit different way. When chemist is looking for the enlightening or the light, chemist is thinking that it is nothing but it is oxidation of the oil in the lamp. Whatever is there, let me start it. It is enlightening, awakening, and we know very well, we start with the Deepa Jyoti Parabrahma, a kind of prayer. Regarding myself, me and Scientone, we are synthesized by each other. So chemistry is applicable to me completely. And now we are with the animation also. My Scientone is animating also. And the coincidence of the chemistry with the Scientone is, the Scientone is originated by a chemist. Probably many of you would be knowing about Dr. P.K. Srivastav, Pradeep Srivastav from CDRI. He is the pioneer of Scientones at international level, national level, and today I am presenting because I came across to Scientone from him only, and the concept of Scientone is disseminated from him to all of us and at worldwide. So it is nothing but it is fusion of chemistry and Scientone. Scientone versus cartoon, when we speak, a very brief, I am talking about the Scientone. Always there is a clash between cartoon and Scientone, and cartoon is catching the Scientone and saying, would you compete with me? So Scientone is saying, no way, I am with information, knowledge along with humor. So we are different, and that's why don't worry, be happy. So let me begin with the story of Indian Chemical Society, and to be precise, let's have a saga of Sage Acharya P.C. Ray, a born star in dark era. Without him, the Chemical Society, discussion of the Chemical Society, Indian Chemical Society is incomplete. So that is, as I said, it is raising the star on 2nd August 1861. He wrote in his biography that was the year when thallium was discovered. So rather than putting him, I put thallium, and thallium is, as a cartoon, thallium is saying that I was discovered when Acharya P.C. Ray was born. From the childhood, he was having very much interest in the practical work. So he made his own laboratory that is well known to you all. I will not go in detail, but that is till today it is fact that classes are not enough. Chemists should have their own lab, and luckily we are having good number of labs in the country. You always think about ancient Indian chemistry, and here he's in the thinking mode. His Scientone is in thinking mode that I have a lot of responsibility of rediscovery of ancient Indian heritage of science. And we know very well the output is there in the history of Hindu chemistry. Acharya P.C. Ray was more patriotic. Of course, he was chemist, but nationalism, patriotism was in high concentration in the Acharya P.C. Ray. So he always thinking about the contribution of Indian science. And he was with the mood of not working for the foreign universities, but working for our country. And that's why this one Scientone is dedicated to his nationalism. Nobel, Alfred is saying, if you work in some European university, definitely you will get Nobel Prize. At that time, our saga is saying, Sage is saying, my nation is much more than anything else in the world. And that is showing the real patriotism in him. So I can put in this way, he's saying, Ma Bharti, whatever I did, please bless me. And today we are knowing about their blessings. So we are aware with this sentence about the leaving the test tube and joining the country's call. I will not go in detail. And the founder person of our Indian Chemical Society is truly the father of modern chemistry in India, master of nitrate with 158 publications. Sir was in the, Acharya was in those days when this H index, impact factor, G index, citation and everything was not there. But if it would have been there, then the question would have been, what about the H index of Acharya P series or impact factor? I think we have no need to calculate it, but the answer is Acharya P series is above all the parameters. And rather than anyone else say, let have Einstein here, and Einstein is saying is absolute. Theory of relativity is not at all applicable to Acharya P series. We know very well about the 150th birth centenary is coinciding with the International Year of Chemistry, and at that time a plaque was laid, and that was for the first time that outside the Europe, this Royal Society of Chemistry, London, put the plaque where he started his career. That is there at the Presidency College, Calcutta. So I can put it in this way: this particular plaque now, because of Acharya P.C. Ray, transferred to India from European countries, and we wish that Indian Chemical Society will give more and more scientists, more and more chemists, so that this will be there in future at many places. It should be there in all the directions of our country. Let me have a little bit about Indian Chemical Society now, and truly for what I am here. We know very well about Indian Chemical Society established in which date, May, and under the leadership of Acharya P.C. Ray, and it was in the mindset of three different people, Professor Jan Mukherjee, Professor J.C. Ghosh, Professor S.S. Bhatnagar, who were there in the laboratory of Professor Donnan. So once Professor J.C. Ghosh was giving the lecture, delivering lecture about the Indian Chemical Society and the history of Indian Chemical Society, and in that special lecture, he explained. Then came in 1921 the Three Musketeers. This is not my word, he used this word, Musketeer, from the laboratory of Professor F.G. Tonnen. Whatever he explained was of course based on the novel we know very well, but I tried to put that Three Musketeers here in the cartoon form, and this Three Musketeers continued the leader Acharya P.C.'s work, and were the initial people for, or dominating people for, the Indian Chemical Society or active members. Now when we talk about these Three Musketeers, Gandhiji would say that, don't you think we should go for Swadeshi? Three Musketeers are not the right way to present. So we put three monkeys. Acharya P.C. has three monkeys from Professor Donnan's lab. And one monkey is saying, I can't see anything other than dispersed phase and continuous phase. I hope I have no need to say about whom I am speaking. The another one is saying, I cannot speak other than the word but CSIR and UJC. I have no need to explain about Professor Bhatnagar. And the last monkey is saying that nothing to listen other than IITs and IISc. So we have these Three Musketeers or three monkeys of Gandhiji in our country. Now, have a different way of putting this Jan Mukherjee and J.C. Ghosh. Acharya is saying, मैं ज्ञानी हूं या नहीं मुझे पता नहीं, पर मेरे पास ज्ञान का भंडार है. Now when Acharya is saying मेरे पास ज्ञान का भंडार है, that doesn't mean he is talking about only knowledge, but he is having Gyanendranath Mukherjee, while another one is Gyan Chandra Ghosh. So the thing I have tried to put in the different way.
Me too. বসো আমি আসছি 10 মিনিট.
Hello.
Gaurashankar, please mute.
हाँ.
Others except the speaker should mute themselves. Sir. Please go ahead.
Oh, fine. So, one chemist would be asking, consider the hypothetical discussion. One chemist is asking, do you have anyone in the, what do you have in physical chemistry? And Acharya is saying, Neil. Acharya is saying Neil. Scientist is not understanding Neil. Yes, Neil. So he was talking about Neil Ratan Dar, who started finding physical properties of nitrates and begin the physical chemistry in India in dominating way. So here it is little bit discussion about those days. Consider there was a phone call in the Department of Chemistry at Calcutta University, and someone is calling and saying, "Hello,
There's
this
no
is
such
there."
thing as first place, second place, and third place when we talk about this warrior
person is
mindset.
answering from the
It's either
university,
you
yes,
live or
but
you
which
die.
PC?
It's either yes or no.
So the
It's
caller
either
is
you
saying
impose
this
your
is
will or
Praful
you
Chandra.
submit to theirs. So when we talk about that
Person
physical
is
discipline,
answering
what I
yes,
need you to
but
understand
which Praful
is,
Chandra?
as you embark on your
His name
training,
is
that
Praful
this is no
Chandra, but which
personal
Praful
game,
Chandra?
that you will break your
So,
body down
again,
and use those
the
pieces
person
to
calling
put
is
yourself back
irritating and
together,
saying,
because every
Praful
time that you
Chandra,
face
chemist.
your adversity that will take
So,
human force,
then
you will have to
the person
strike
is
it with the
answering
metric
yes,
force of a
but
ton.
both
I
are
need you to
chemists.
understand.
So some confusion is there, and the person is answering from the university department. University department,
but
no
he's going to explain
confusion.
a little bit more about
There is
what
Acharya
McMath
P.C.
is
Ray
and why it's
and
important
his
to be trained
disciple
towards McMath.
is
Hi, what's up, guys? So
Dr.
you've
P.C.
seen me before. I'm
Mitta.
over here with this
And
motivator.
for your kind information, both are Praful
McMath is
Chandra.
going to be pretty much the martial arts for the Marine Corps. All right. So
I have
a lot of
a
you guys have
cartoon
seen
of
jiu-jitsu, boxing,
Dr. P.C. Mittal, who is very happy.
you name it. The
to say
difference
that
between
I'm sharing
McMath
my
and the
name
rest of
with,
the sports
name and
is that our
blessings of
art
Acharya
is for
P.C.
combat. All right. Any one mind, any
No,
weapon.
at that
Makes
time,
sense. So
there
we're
were so
very
many
proficient.
people.
Doesn't
I
matter
got
whether
the
there's a
information
rock
from
or there is a stick. We
website.
are going to utilize
So
any
today
weapon
some
around
teacher
us
is
to defeat
explaining
the enemy
that
and
what is your comment
gain the
about this
tactical
group?
advantage. All right. So
And one student
pretty
is
much
raising the hand and answering.
the reason why we're
It
here
is
today
homogeneous
is
blending
because
of chemistry.
my brother decided that he wanted to
teacher
learn
is
a
still
little
not
bit
happy, so
about
he's
my
asking
passion, which is
some
the
more
martial arts
appropriate
program. So
term.
we kind of took him
And,
to a whole
the
course
boy is
on how
saying,
we do business as
consider
far
it as
as
the
the
cocktail
bill
of
system.
chemists. So
We are
I
very
would like to
passionate
say
about this
that
program,
time we
especially
had
myself.
cocktail of,
It's definitely never given, it's always
dedicated
earned.
chemists in India.
And it has to do with the three disciplines. So
First
we preach
issue
about physical,
of
character,
Quaternary
and
Journal,
mental. And that's
Journal,
why McMath is so
Journal of Indian
important. It doesn't matter how lethal you are. It doesn't matter if you're a stud. If you don't have the three
24.
disciplines, then
So
you're not
how
good to us.
something
And what we
regarding
mean is
that?
you have to be physically fit
One chemist
in
is
order for you to
thinking that where should I
be
publish my
lethal
research?
whenever you're in this
Now,
combat
to have
scenarios.
the
You have to
confirmation
have the
that this
character, because at the end of
chemist
the
is
day,
Indian,
that's
we
what
can
separates
have,
Marines from everybody else.
completely
We're not
Indian,
killers, we're protectors of
clothings.
life. All right.
So now we can
you need to have
understand
that
this
good
is the
character. Are you going to
best
be
of
a
those days.
problem everywhere that you go,
he is looking
or are you
here
going to
and
be a
there
solution? Is
that,
the room a
where
little
can I
bit safer
publish?
because
And
you're
when he
there?
is looking
All right.
here
And
and
then the
there,
mental portion is
someone
extremely,
appeared
extremely important,
and
because
said, "Dear
as you
fellow,
guys know, you're going to
I
hit
was
that barrier
surprised
on the
to see
physical
who is
aspect,
there."
or there's going to
And
be
he
those
found
choices where
that
people are going to tell
Ma
you to drink
Saraswati
and get in a
is there.
vehicle and drive,
And
but
Ma
that's where that
Saraswati
mental
is
comes
saying,
in.
"I have
As far
already
as
placed
you
the
combine
efforts
only with the
of
character, making that right
ICSI
decision so that everybody else around you,
and
it's a little bit
now they
safer
are
because
publishing
you are
Journal
there.
of
So
Indian Chemical
kind of like
Society.
in a nutshell, that's
So
what
our
McMath
journal
is
is
about. It's
placed
about
truly
us
by
making sure that we are
the
lethal whenever
goddess.
we go to combat.
And we know very well about their value, their importance, and we know that William Palmer Winey, then the president of Chemical Society of London, he gave a call and congratulate Acharya P.C. Ray. So that is automatically indicating value of our chemical society. Even Nature published this. That is already known, and I have no need to revise. So today, any chemist from the India can say, sir, today we are enjoying the fruit of our work, and that is nothing but Indian Chemical Society. If someone is trying to just go through the numbers, what about the indexes? So computer is answering, or you can say in true sense, computer is talking with the ethics. That proud, respect, love and affection need no index. Today Indian chemists are publishing because of proud, respect and love with the Indian Chemical Society. So meanwhile in the tea time, probably the hypothetical discussion is going on. One is saying who can be member or fellow of chemical society of this society, and another member is answering anyone. He or she should react with the society properly because it is chemical society, so there should be proper reaction. I'm trying to put this person as a symbol or as a person from the Indian Agriculture Research Institute, Indian Krushi Anusandhan Sanstha, and IARI is thinking about one person. Probably from the diagram one can understand, and IARI is saying that thanks for always providing good human resources like Jan Mukherjee. We know very well about their contribution to agriculture. And at that time, our society is answering silently, we are here for the entire nation. We are here for developing the human resources for the entire nation. Now, we have very good journal, that is Education in Chemical Science and Technology. So have the cartoon where teacher is teaching the chemistry, and teacher is asking, do you have any stuff for teachers? And one chemical test tube is appearing and saying, they have special journal for you. ICS is working for chemical education also, and education in chemical science and technology is the output known to us since 2013. Consider putting it, why we are putting in the on the internet, and that is again free. So cartoon is asking why we are putting it, and the answer is because the foundation is laid by Acharya. Acharya means teacher, and it was not laid by any industrialist or any commercial person, but by Acharya. And another thing, we are from the land of the Jagat Guru. Tomorrow, if the world will be having one village, then definitely the Jagat Guru will be from India. We are from the land of Jagat Guru. So, have the another cartoon where a chemistry teacher is teaching and the boy is raising the hand and asking, sir, are you reading Education in Chemical Science and Technology? This will be the future. This will be the value of our journal in the education field. Have a little bit about the Chemical Varta, which we started recently, and I will not take much time. So, Chemical Varta is saying, be ready for upcoming conferences, seminars, and other chemical reaction, right? And I have no need to say, and if cartoon is not proper, please excuse me, sir. But our president is saying, please do contribute to Chemical Varta to make it attractive and readable. Chemistry related cartoons, photographs, poems, and likewise anything can be submitted as explained by sir. So my cartoon is saying, hats off to you, sir, and the entire team of Indian Chemical Society for giving this opportunity to me. So in coming days, there will be scientific cartoons related to chemical in the Chemical Varta, in the magazine. And same way, the most common, my photograph or my iconic way, my sign tone is saying we will definitely react on this aspect. So there will be reaction in the Indian Chemical Society. I have no need to say who is this, Professor Chittaranjan Sinha. Please, sir, if it is not proper, excuse me, but I want to make it funny, right? And you are with Chemical Varta and explaining
Whether
possibly
you're a
it is
fine
the
art
first
aficionado
of
or
this
struggle to
kind
tell your Da
published
Vinci
by
from your
any chemical
DiCaprio,
society in
there's no
India.
denying that the
And
world
it
of
is
art and
very good
museums
for
can
the
be
layman.
amusing.
So
Sometimes.
layman is reading and layman
But
is
what
saying
makes the
it is so
quiet
simple
halls
that
of
layman
these
can
types of
understand
places
it
more
very
fun
well.
is when
So
the
this
truly
was
unexpected
glimpse.
happens.
I don't
From
want to go in
onlookers
complete
mistaking
detail of the
random
history,
everyday
and
objects for
we don't have
priceless
enough
art,
time also.
to the countless
But
people
here,
who've snapped pictures with their
I come to
museum
conclusion.
doppelgangers.
Thank you
Let's
very
check
much
out
for
some
providing this
hilariously
opportunity for brief history of Indian Chemical Society. Thank you very much, and we'll have more fruitful interaction in the future. Thank you again.
Okay. Thank you very much, Mr. Vishal Mullia. It was really very attractive, at least for me, and I believe it is for the entire audience as well.
Thank
So
you.
let us have some comments or queries from the audience.
Please.
Sir, first comment from my side, sir.
Please.
Sir, first of all, I am extremely sorry my mic was on for a certain time.
No, that's
my
okay.
finger was put in somewhere. So I will request Vishal sir to contribute some of your cartoons in our Chemical Varta, because I am the editor of that. And I am
Definitely, sir.
I will be very happy if you contribute something in our current issue, which is going to be published in March.
Sure, sir. Sir, whatever the kind of syntones you are requiring, just send me brief that.
Yes, sir.
this
Yes, sir.
is the
I will
particular
send it
research.
you the.
Yes.
I will send you the cover page and the theme of this issue within 1 week.
Shankar, I think you should have a talk with Mr.
Yes, yes.
Mullia over phone and explain, what is the requirement.
Definitely.
What is the expectation? Huh? Okay. Okay. Any other comment, question, queries?
This is all right, sir.
Huh?
Thank you, Mulia.
No, I have two small comments. Okay, so taking to it proper humor also. Professor Chittaranjan Sinha, that cartoon looks like a mixture of our Professor Jadhav and Professor Sinha. Combination of both our president and honorary secretary of the Indian Chemical Society. And the other thing that I like to point out to Mr. Mullia is PC Rais Acharya Prafulla Chandra, not Praful, Prafulla. It's double A. Okay. Don't take it, hard.
No,
Just it's a simple, correction in spelling. So that I'm suggesting. Okay.
Sir, I am from biology background, and
No
this is the
problem.
first time
It has
I
been
come
it
across
has been
to
really
Indian
enjoyable.
chemical.
No criticism. Okay, just a small correction I'm suggesting. Okay.
At
So,
that time, Prafulla Chandra had the 4 Prafullas.
yes.
The 2 are already have shown Prafulla Chandra Mitra, and Prafulla Kumar Sarkar. He was also the chemistry student of Acharya Rai, and he helped to write Atmacharita. In fact, Prafulla Kumar Sarkar, the editor, the founder editor of Anandabayar Patrika,
Yeah, yes.
ABP Ananda. He was the founder editor, and he wrote that Atmacharita in Bengali. And another Prafulla, this is Prafulla Ghosh, who was the chief minister of West Bengal. He was also the student of Acharya Rai.
Yes.
Okay.
Anyway, thank you very much. Thank you very much, Dr. Mr. Mullia. It has been really, very different and equally enjoyable to all of us. Thank you very much.
Thanks.
Thank you. So now I, hand over this, podium or virtual podium to Professor Chittaranjan Sinha. Please.
Thank you, Professor Bhattacharya, for his wonderful chairmanship and conducting the session of 3 speakers of different tastes. Now we are going for the valedictory session, which is in fact the time for the declaration of the results and retrospective of the programs of the Indian Chemical Society as well as its future projection. In fact, all our senior members of the society are now engaged in the different programs in different places. For example, one program is now running in Bhagalpur, where the Professor Mukherjee and Professor Sudip Das there, and our president, Professor G.V. Jadhav, now engaged in another program in Bombay. So that today whole country is celebrating this National Science Day. It is not that Science Day does not refer to only the teaching of science. Rather, I told you in the morning, the science temperament, what is happening in the country now, you just remember the most cited institute of the country, one of the IITs, where the students and all other people, they're practicing how to make cow dung. Cow dung and urine of cows are now they are proposing to use as the medicine against corona. Is it a science? Science, they in fact talking about against all these superstitions and anti-science or half science or pseudoscience. So Science Day in fact develops the inquisitiveness amongst the students as well as all the people, which is also the idea of our Upanishad, that is the jigyasa. You just ask queries, ask questions. And science, in fact, is a philosophical term which finds the truth. And Swami Vivekananda, who defined science, is the journey of truth to more truth, not from false to truth. But today, what is happening in my country, the highest body who is governing our university education system, they are proposing to teach Hastarekha Visharad. They are proposing to teach Vastu Tantra. They are proposing to teach, those are anti-science, unscientific. So Science Day celebration also is against all these types of superstition and anti-science attitude. If you remember the letter sent by Swami Vivekananda to his first disciple, Al Singha Perumal from Chicago, he wrote that we in India, we don't have any problem. We are not worrying about the problem of unemployment. We are not worrying about the problem of poverty. We are not worrying about the problem of illiteracy. We are worrying about the problem of superstition. So you have to fight against superstition. So to talk about against the superstition, many of our countrymen, those are the front runner, they are some of them are the journalists, some of them are the university vice chancellor. They were being killed by the terrorists. Even Gandhi had been shooted by this type of terrorist. So friends, the Indian Chemical Society, Acharya Prafulla Chandra Rai, throughout his life, he did not practice any illogical, unscientific, or unrealistic function or work in his life. In his every write-up, every literature, in his every topic of discussion, he talked about the scientific attitude. So Indian Chemical Society today in its program is trying to disseminate or inculcate the same truth what Acharya Prafulla Chandra Rai inculcated and suggested to us. And now the time for the declaration of the results, and we will send the certificate to the participants. All the participants will get the participant certificate along with the certificate for their achievements in their competition. Let me to display the table of results. It will come quickly, I think. I think it is coming. Is it visible to you all, sir? Class 5-6, Group A, Ohana Maji from Kontai Public School. In speech, she stood first. She belongs to class 6. And Obhirup Pal from the same school, Kontai Public School, in model, class 6, he stood second, Obhirup Pal. And Samriddhi Pode in poster, class 6, Puspata Ghatal. He stood third, along with the Devosmita De from Bishop George Mission School, Beleghata, Kolkata. She stood third, so joint third. And in the group B, class 7 and 8, and Swastik Das in speech and poster stood first from Kontai Public School, Kontai, West Bengal. And Minnat Jahan from Tiljala Banitirtha High School for Girls. In poster, she stood second of class 8. And Orchita Prasad from same school, Bishop George Mission School, Belegata. Orchita Prasad stood second from class 8. And Ayushman Banerjee in speech and poster from Bishop George Mission School, Belegata, stood third. And in group C, class 9 and 10, Tathagata Das in poster, Tiljala High School, Higher Secondary, he stood first. And Ankita Kumari, Bishop George Mission School, Belegata, stood second from class 9 in poster. And Bishop George Mission, Sanvi Sharma stood third from Bishop George Mission School in poster. And also Shreya Singh from Bishop George Mission School, Belegata, she stood third, that is joint third. And group D, class 9 and 10, Ronit.
No, 11 and 12, sir.
Yes?
11 and 12.
11 and 12. Group D, 11 and 12, Ronit Vijayanand Chobe from Adarsha Mahavidyalaya of Computer and Management, Akola, stood first from class 9 in poster. And Oyan Das, Bishop George Mission School, Belegata, he stood third. He is from class 11. And Ganesh Kollan Kolonkar, Wilson College, Girigaon, Chowpatty, Mumbai, she stood second from class 9. And for UG and PG students, joined first Mr. Abdul Mutakabbir Sarkar in poster from Jadavpur University, and Mrs. Ratnasri Das from IIST Shibpur stood first, joined first, and Mr. Rohit Chatterjee from Haldia Institute of Technology, he stood second in poster, and Mrs. Sheikh Rohima Aiji, she stood second from BPMK Arts, Commerce and Science College, Kinabali. And Mrs. Dinkar Kriti Rajesh, BPMK Arts, Commerce and Science College, Kinabali, stood third in poster. And Mrs. Chandri Talukdar, Bidhannagar Government College, stood third in poster. So joint first, joint second, and joint third in UG and PG portion. And in Group F, as research scholars competition, and faculty members, Dr. Sunil Gaikwad from Dr. D.Y. Patil ACS Women's College, Pimpri, Pune. Dr. Sunil Gaikwad in oral presentation, ranked first, and Shokupta Hawk from CSIR, IICT Hyderabad, stood second, and Ribhu Maiti, Mugbedia Gangadhar Mahavidyalaya, Purva Medinipur, stood third in poster, and Dr. Basudev Datta, IIACR from Kolkata, he stood third in oral presentation. This is the declaration, and we will send the soft copy of their certificate, and all the certificates of their participation will also be sent from our office. If you won't get it, then please contact with us. This is all about our results declaration. Hello.
হ্যাঁ স্যার বলছি যে আমি তথাগত দাস বলছি আমাদের কি সার্টিফিকেটটা ওখানে গিয়ে কালেক্ট করতে হবে নাকি আমরা অনলাইনে পেয়ে যাব?
না, অনলাইনেই পেতে পারবে। আমরা সফট কপি পাঠিয়ে দেবো। কন্টাক্ট দেওয়া আছে।
গ্রুপে পাঠিয়ে দেবেন তো?
তোমার তো কন্টাক্ট ডিটেলস দেওয়া আছে আমাদের কাছে। Send by that contact details, that is your email ID, we will send it.
Okay sir, thank you very much. Okay.
So this is all about the declaration of the results, and I think all senior persons are not here, so I may request our Professor Somaresh Bhattacharya to chair this session, and then our interaction with the participants as well as different judges on the session, how to improve our quality of interaction or any other model may be developed with reference to the activities of the Chemical Society. Professor Somaresh Bhattacharya, please.
Oh, I did not understand what you said. What should I do?
You will conduct the chairman of the session, where you will interact with the presenters or the participants, and we will take back their any type of instructions or any
valedictory
in the valedictory session.
Oh, okay. So comments from the participants, right?
Participants, yes, sir.
Okay, so particularly younger participants, if you have any comments, any criticism, any suggestion for improvement, please raise your voice or hand maybe. So anybody in the audience, I can see only 47, including me, participants. So if anyone wants to say anything, you are welcome. Did you enjoy the presentations? What was your expectation? How much of that has been fulfilled? So all these aspects you can consider and comment. Gauri Shankar, I don't know whom I should have. Basudev Datta, are you there?
স্যার কিছু বলছেন স্যার?
হ্যাঁ, if you want to say something, I don't get any participant to interact, so I'm trying to pull you.
Okay sir. So my comment is that today I have some new idea about the what we are doing actually, because how PC Rai had thought and what we are doing, there is a big gap. And probably that big gap have been identified by this cartoonist, Vishal sir, and I must acknowledge his contribution to mention that gap, especially in case of chemical Barta and chemical education, both I am handling. So we need to more focus on that, because he has today tried to popularize it by his own way. So I, being one of the editor, I will try my best to give my that is much effort to make these two, one this chemical Bartha and this one journal to popularize more. And at every time I request to all seniors to contribute something toward the chemical education. And I should not repeat the name. So it is the request to everyone. And one thing more that what we have done to, it is for all audience, that is from Chemical Bartha is publishing from 2013, but from volume 1 to volume 7, volume 6, there was no ISBN number, but we recently got that. That is, we have received the ISBN number. So we are going to reprint it again. And in that case, volume 1 will be intact as it is. There will be no change in the article numbers. But most of the other volumes are less than 100 pages. So we are going to increase it to 150 pages. So some college teachers or the university teachers who want to contribute some topics on that particular portion, we can include at least 4 or 5 articles in each volume. And another thing, we are going to publish the volume 10 in our 9th May. Okay. So it is my earnest request to all of you to contribute something such that we can make it possible.
Okay. Thank you.
And another thing is, sir, it is for you, sir. That is in our today Kollol sir is not here. So as a member of that body of these accounts of chemical education is research, we have received 15 consent all over India by some senior scientists for their articles, and already 3 we have received.
Yes, yeah, I know that, because he circulates all the mails, everything amongst all of us.
Yes,
so
sir. Yes.
I'm aware. Okay, thank you, Gauri Shankar, for your feedback. Anybody else? I see some not so familiar names. Abu Tahir. So Abu Tahir, if you are present, want to say anything?
Yeah, sir.
If you want to, express your feeling,
Sir, I learned a lot, sir. It's a good experience. I have tried my best, and I have done my best. So I have gained many ideas, sir, from different states, different countries. So it was very good, sir. Thank you for giving this opportunity, sir.
Okay, thank you so much. Anybody else? So no one is volunteering.
Sir, I am Srijit. I was your student in Jadavpur University. I did my PhD under Professor Umasis Jana. Okay. So you and Chittaranjan sir are my teacher. So in group E, UG and PG session, I was one of the judges panel. We were 5 judges total. So okay. I want to share something about how to improve the quality of the presentation.
Please.
So first of all, during the last almost 2.5 years, we are very much used to with this online interaction, online presentation and these things. But this is not the actual presentation. So most of the time, students should remember that they need to present in an auditorium. It can be big or middle-sized or small size. So during preparing the presentation, I would suggest not to use any dark color background. And I saw that some students made their presentation, the text of the presentation was too small, that it is visible in the laptop or in the computer, desktop computer, but in the big auditorium hall, it will be completely invisible. So that should be taken care by student, and also try not to write paragraph in slide and read line by line, because people will see the presentation and listen to you. If you write too much in the presentation or in the slide, then people will not tend to listen you. People will only see and try to read the slide. So there will be no difference between reading a journal and listening to a presentation. So you need to understand, you have to understand the difference, and that you are reading a journal or you are participating in a presentation ceremony or presentation work where people are presenting. So there are difference. So for that difference, you have to be very precise. You have to write some whatever you want to say in point wise, and the remaining part, what you have written in today's presentation, that need to be discussed orally. So it is a oral presentation. And also I saw that many students used different kind of stylish background, so that 1/4 or 1/3 of the slide was blocked with some color or with some picture. So you have a very less amount of slide left for your material. In chemistry, this is not necessary. In other field, maybe it is necessary to make it more beautiful or good looking, but in chemistry, the material is the main issues and main things people will see and people will understand. So try to make blank slide, white background, or very fade color black background, so that everything can be understood. And also I have one point that it was multidisciplinary in group E, the UG and PG students, someone from chemistry background, someone from biology, someone from other backgrounds. But if you are presenting a particular topic, then the basic ideas or basic terminology, at least you have to Google it and you have to understand the definition of this terminology. Some physics student is presenting about coronavirus and telling that coronavirus is, in some point of time, he is telling about secondary metabolite or primary metabolite. Then, although you are a physics student, undergraduate student, you are not, we don't expect that you will understand what is metabolites and what metabolism is, everything in detail. But as you are presenting in a particular topic and you are using that particular terms, so you have at least, before presenting, you have Googled it, you have to Google it and know that what is metabolite, what does it mean by secondary and primary metabolite, because questions are very much obvious, especially when you are using in your slides. So whatever you are telling, you are presenting,